We are adding to the notes from last night. So we have 36 to the negative 3x equals 216 to the 2x. And if we look at the chart, which column has a 36 and also has a 216? Which column has a 36 and a 216? The 6 column. The 6's has a 36. That would be 6 squared. And it also has a 216. That would be 6 to the third. Okay, so I'm going to rewrite this as 6 squared. And I'm going to rewrite the 216 as 6 to the third. So there's the problem that I have. And when you have an exponent raised to an exponent, what do you have? What do you do with the exponents? You multiply them. So 2 times negative 3x is negative 6x. 3 times 2x is 6x. And if the bases are the same, we can just get rid of them. So we have negative 6x equals positive 6x. And a lot of people will look at something like this and they'll be like, isn't that a no solutions answer or an all solutions answer? And the answer to that is no. There's an actual answer for this problem. So it's not negative 1. So we're going to get the x's to one side. So I'm just going to go ahead and add the 6x over to the other side. So we get 0 on the left side equals 12x on the right side. So our goal, even if we're looking at a problem that could be no solutions or all solutions, our goal is going to be to get all the x's on one side. And if it's a no solutions or all solutions problem, then you're going to get rid of your variable when you do that, and you're going to get something that's either not true, which would be a no solutions answer, or you're going to get something that is true, which would be an all solutions answer. In this case, when we get the variables to one side, it actually happens. You get the variables to one side. So this is a problem where you actually have a solution. This is not a no solutions or all solutions problem. You actually have an answer here. So here we can just divide by 12. And 0 divided by 12 is an answer. It's just 0. Yeah, 0 divided by 12 is just 0. Right. Now, there's something that I had not taught you in the calculators because I didn't want to overwhelm you before, but we have done a lot of different things in Math 3 where we have solved equations, and so I want to show you guys how to check your answers because I think at this point we're getting pretty comfortable with the calculators, and so I think I can show you something today without your brains exploding. So I'm going to show you guys how to take an answer that you have found and store it in the calculator so that you can plug it back into an equation easily. So, we have what? A calculator thief. Can we check the tables? Did anything drop? Everyone want to check your tables and see how many calculators you've got? I think that, nope. You guys have 4? You guys have 4? You got, but do we have any extras? There's 3 over there. There we go. That's where it is. All right. Okay. So we have the answer to this problem was 0, so I'm going to type 0. And then right above the on key, there's a key that says STO, and that means store, as in you're storing a number. So I'm going to hit STO. And then I'm going to hit the X button. So I'm going to say, in my calculator, I'm taking 0 and I'm storing it as X. Okay? So I'm taking 0 and I'm storing it as X. And when I press enter, all it does is it puts 0 there. So I'm taking 0, I'm storing it as X. So now So the way I did that again is I type 0, and then I type the STO button right here. It's above the on button. 0 STO X, and it looks like this when you do it. And then you press enter, and then it stores the number for you. All right, so now what I can do is I can type the left side of the equation in using x, so 36 to the negative 3x, and I can see what the left side of the equation equals. And then I can type the right side of the equation, and I can make sure that both sides of the equation equal the same thing. So it's an easy way to plug a value in for x where you don't actually have to like plug that value in for x, because you have that number stored as x instead. Okay, so I plugged 0 in, I plugged it in on the left side, it equaled 1, I plugged it in on the right side, it equaled 1, and the left side and the right side equaled the same number. So that means I got the answer right. Okay, all right, let's do another example, and then we can check it once we're done. So this one is going to be 9 to the negative 2x equals 1 over 81 to the 3 minus x. All right, so which column are we going to use? The 3's. You can use the 3's. Now you can actually use a column that's not even on the sheet because I didn't make the sheet this big. We could use 9's, okay? So, you found them? There you go. Okay, so we can do 3's or 9's. So I'm going to do the problem both ways just so you guys can see how it would change the problem or keep the problem similar to be able to do 3's or 9's. And the reason I want to do the problem both ways is because if you guys compare the 2's column with the 4's column, you'll notice there's a little bit of overlap between the 2's column and the 4's column. You can see that some of the numbers are the same if you compare them. So the 2's column and the 4's column often come into play on the same problems. The same thing with the 3's column, and if we had it, the 9's column would do the same thing. So I'm going to do this problem two ways. In one of the ways, I'll leave this as a 9. 81 would be 9 to what exponent? It'd be 9 to the... So 81 is 9 to the second power, but if it's a fraction, it wouldn't be, it'd be negative 2 instead. Okay, so this is if we did the 9's for the base. Now, if I did 3's for the base, it would be 3 squared to the negative 2x. And then what would 81 be? What would 1 over 81 be? 3 to the negative 4. Perfect. Okay, so we're going to solve this problem two different ways just so we can see what happens when you use two different bases. Okay, so we have an exponent raised to an exponent. What do we have to do with those exponents? Multiply them. Okay, so this one stays the same. This would be 9 to the negative 6 plus 2x. Okay. This would be 3 to the negative 4x. 3 to the negative 12 plus 4x. Okay. And then at this point in both of our equations, we are good to get rid of the bases. So negative 2x equals negative 6 plus 2x. Negative 4x equals negative 12 plus 4x. So you could add, now if we add the 2x, that's going to get everything on one side. Do we want to do that? No? Okay, so do you guys want to do that? Add the 2x and then add the 6 so you can keep everything positive? Yeah, we could do that. So add the 2x, and then we could add the 6 and add the 6. So 6 on the left side, 4x on the right side. We can do the same thing over here. So add the 4x, add the 4x, add the 12, add the 12. So 12 equals 8x. Do you guys see how similar the two situations are? Yeah.
So basically, if your number you start with is bigger, your answer is going to be more simplified.
So if your base is bigger, that means your exponents are smaller. And so then you're going to be dealing with smaller numbers throughout the problem. Whereas if you have a smaller base, then your exponents have to be larger to account for that smaller base. Yep. That was a good clarification. Okay, so now what do we need to do? Divide. Divide by 4. Divide by 8. So x equals 3 over 2. So divide by 2 on the top and bottom over here. Divide by 4 on the top and bottom over here. But it's 3 over 2 regardless. So it doesn't matter what you change your base to be. You're going to get the right answer. Okay? Now, a bigger base is going to allow you to deal with smaller numbers throughout the problem. A smaller base is going to have you deal with bigger numbers throughout the problem. So that's the only difference in your decision with what you make. Okay? So there's going to be some problems that when you set them up, you're going to be like, oh, I could do this problem with a base of 4, or I could do this problem with a base of 2. How do I know which one I should use? And the answer is both are fine. You just choose the one that you prefer. Do you like bases of 2? Use 2s. If you like bases of 4, use 4s. Same thing with this one. We could use 9s or 3s. It doesn't really matter which one you use. It's based on your comfort. Okay? So let's go ahead and check this answer. So I'm going to do 3 over 2 stored as x. So 3 over 2 stored as x. Okay? And then I'm going to type in 9 to the negative 2x. And that gives me a funky decimal. And then I'm going to type in 1 over 81 to the 3 minus x. And it gives me the exact same funky decimal. So I know that the left side of the equation and the right side of the equation equal the same thing, which means I got the answer right. Yeah. Yes. Test on a Monday. Quizzes tomorrow, yeah. This is a really short unit. Because it falls on a Monday.
Move it in the light more. Like move it to there you go.
Okay. All right, we have one more example.
When do we go get our test back?
I'm getting very close. It was so yesterday I went home and I went to sleep right after I got home. So I had like a 6 p.m. bedtime. I don't know. I don't know, I can't speak for most teachers, but I think that most teachers don't like grade 1 tests from start to finish. Most teachers I've known grade 1 page at a time. So I only know whose test I'm grading for the first page. And then after that, I have no idea whose test I'm grading. Because I'm like, page 2 for everybody, page 3 for everybody, page 4 for everybody. So, all right. One more example, just to make sure we've got it. This one also gets a little funky. $625 to the negative 3x plus 3 times $625 equals 125 to the 2 minus x. Couldn't you do what? 25. So this one would not be 25 to a power. It would be 25 times 5. So 25 you wouldn't do. 5. You could do 5. So if we look at the sheet, if we look at the 5s, 5s would work because we got 125 and we got 625. Okay, so the 625... Bigger than 5? No. No. So we've got 5 to the 4th to the negative 3x plus 3 times 5 to the 4th equals 5 to the 3rd to the 2 minus x. Okay, so for the first term, we distribute this because we're multiplying our exponents. And what's our new exponent? Wait, negative what x? Negative 12x plus 12. 5 to the 4th. 5 to the... Okay. Okay, now before we do some more simplifying, I'm going to remind you guys of some math that you know. You know that x to the 2nd times x to the 5th is x to the 7th. And how did you know that so quickly? You add the exponents. Okay, so over here, what do you do with these exponents? You add them. Well, tell me, what's negative 12x plus 12 plus 4? Negative 12x plus 16. A lot of students aren't used to seeing this property written like this. And so they forget that they know it. So you do know this property, you're just not used to seeing it like this, you're used to seeing it like this. Okay? So when you are multiplying these together, you're just adding your exponents, that's all you're doing. You've done it before, you just haven't seen it this way. Okay? So negative 12x plus 12, and then we added the 4 to it, 12 and 4 gives us 16. That's all we did. We added our exponents together. So the only thing that was complicated about this problem is that it added one more step of adding some exponents. But now it's just like the rest of them. Now we've got one base and one base. We can ditch the bases and we can solve the equation like normal. So how would you guys like to solve this? Add 12? Okay. Add 12x, add 12x. And you said minus the 6.
Why did you only subtract? Oh, you subtracted 6. Right.
So if I want to check my answer, I can do 10/9 stored as x. And then I can do 625 to the negative 3x plus 3 times 625. Get 73 with the funky decimal, and then 125 to the 2 minus x, and I get the same number with the same funky decimal. You got the same funky decimal? Did you get this? Oh, you need batteries. Okay. Can get this. All right. Does that make sense? We good? Okay. So, for today's class, you have an around the room activity. You start with any problem you want to start with. Also, for your viewing pleasure, every single problem has a math meme on it.
Really?
I took the time to put a meme on every single problem. You're welcome. Never say I don't care. Some of them are actually really good, too. Some of them are really good. Yes. What? No. You got to get up and walk. This is math and PE together at the same time today. All right. So, start on any problem. It doesn't matter which one. Do it on a separate sheet of paper so you don't have to turn in your notes. Go ahead and get started. Yesterday? We were gone yesterday? Yep.
What's your problem?
No, walk around. Have fun.
Hey.
I didn't do the notes last night, so I just do the notes and then get the what's it called?
How are you feeling as far as seeing 3 examples? Do you want more examples?
No, I'm fine.
I'd say do the activity, and if you feel like you need more examples, then you could watch the notes.
Okay, and do I still need to turn in the notes? You still want me to do them?
There's a chance I might not even check them this time.
Okay, so I don't have to worry about it?
I wouldn't worry about it for now. I'll let you know if you need to do them.
Okay, thank you.
Assignment, so that will be nice. So there is no video for homework tonight. No video. The homework tonight is going to be a quiz review. Okay? It's 1 page. Well, it would have been 1 page if I didn't kill trees, but I did kill trees, so it's 2 pages. But it was supposed to be 1 page. Okay. So for the notes that we're going to finish with, we're going to say this is how we convert between exponential and log form. Converting between exponential and log form. So the first version that we're going to do is starting with an exponent and converting it into a log.
This sounds complicated already.
It's not. This part is pretty easy because exponentials and logs are inverses of each other. Just like adding and subtracting is inverses. Those are inverse operations of each other. Multiplying and dividing are inverse operations of each other. So if somebody said, oh, I just multiplied by 5, how do I do the inverse operation? You would say, oh, divide by 5. If I said I just added 7, what's the inverse operation of that? You would say, oh, minus 7. So if I said I have an exponential problem, and my exponential problem has a base of 3, what should I do? Then somebody else would say, oh, just use log with a base of 3. That's the inverse of it. So the difference between exponents and logs is just using a base that is the same. Okay? So this is an exponential problem. This is a fact, an exponential fact that is true. 3 to the 4th power is 81. That's a true statement. And so to convert this into log form, I just have to use log with the same base. So this has a base of 3, so I'm going to do log base 3. And whatever I do to the left side of the equation, I have to do to the right side of the equation. So because log base 3 and exponential with a base of 3 are inverses of each other, they cancel each other out. So log base 3 and a base of 3 cancel, and it just leaves a 4 behind. And then on the right side, I have log base 3 of 81. So I just took that fact, 3 to the 4th equals 81, and I wrote the exact same fact, but I wrote it in log form. 4 equals log base 3 of 81. Those are the same facts, it's just written in 2 different forms. Okay? Let's try another one. For this one, I'm going to write 81 equals 9 squared. So what is the base of the exponential problem? 9. So what base should I use with my log? 9. So I'm going to do log base 9 and log base 9. And because we have log and exponential, and those are inverses of each other, they're going to cancel each other out. So log base 9 cancels with the base of 9. And then on the left side, I'm left with log base 9 of 81. And on the right side, I'm left with 2. Log base 9 of 81 equals 2. That's it. That's all you have to do. All right, somebody give me an exponential fact that's off of your chart. Somebody tell me something that's true. Okay, so we have 5 to the 4th equals 625. So what log am I going to use? Log base 5. So I'm going to do log base 5 on the left side. I'm going to do log base 5 on the right side. The log base 5 and the base of 5 are going to cancel. And I get 4 equals log base 5 of 625. That's it. So all you have to remember is to use the same base, and the base cancels the base. Okay? All right, let's try a funky one. I'm going to have to use my calculator real quick for this one. I'm going to say e to the 8th, and then I'm going to use my calculator to see what decimal that equals. E to the 8th. Oh, ugh. Okay. Equals 2980.958. Okay, equals that crazy decimal. Okay. So what am I going to do? I'm going to log base E. Okay, log base E the left side. And then I'm going to log base E the right side. Anyone remember what E stands for? 2.718. And what's it called? Euler's number. Okay. Not Euler, Euler. Okay, so I'm going to cancel this out. So 8 equals log base E of 2,980.958, but we don't actually write log base E. Anyone remember what log base E actually is? It's ln. It's ln. 8 equals ln of 2980.958. Let's check it and see if that's close. It's going to be not perfect because we rounded decimals. But if I do ln of 2980.958, is that approximately 8? Yes, it is. Ta-da! Okay. All right, let's do it back the other way. Let's do log into exponential form. It works exactly the same way. So we're gonna take the same base and we're gonna use it to get rid of the base, just like we did before. So I'm gonna start with an exponential example, or I'm gonna start with a log example. So I'm gonna do, let's see, log base 2 of 32 equals 5. Okay. And we're going to turn it into exponential form. So what base should we have in the exponential equation? 2. So I'm going to put a base of 2 in the problem and a base of 2 in the problem. And so the 2 and the log base 2 are going to cancel, and I just get 32. And then this is going to be 2 to the 5th power. Is it true that 32 equals 2 to the 5th power? That is true. Okay, let's try another one. Let's say 2 equals log base 5 of 25. The base is 5, so I'm going to put a base of 5 over here and a base of 5 over here. And the base of 5 and the log base 5 cancel each other out. And so on the right side, all I have is the 25. And on the left side, I have 5 to the 2nd power. Is it true that 5 to the 2nd power equals 25? Yes. Okay, so when we convert between the two forms, we just have to make sure that we choose the base. And then we take that base and we use it on each side. If it's an exponential problem, we do log with that base on each side. If it's a log problem, we take the exponential and we make that the base on each side. Does that make sense? Okay. So I have 2 things to give you. One, I have an extra credit page of these problems that you can choose to do if you want. And then 2, I have the quiz review to give you. That is not extra credit, that you have to do. Okay? And that's all we're doing. That's it. Okay?